One. In the last class, we finished off the motor system, and in the last one, we discussed about the differences between the upper motor neuron region and lower motor neuron region. There are so many differences that you can watch in the previous video, but one point is quite peculiar regarding the upper motor neuron region. Normally we say the lower motor neuron region reflexes will be lost. Why? Because we know there is cut in the lower order neuron, so there will be the loss of the reflexes. But in the case of the upper motor neuron region, we just say, generalized term, we say the reflexes are exaggerated, but that's not the complete truth. The complete truth is deep tendon reflexes, they are exaggerated, but superficial reflexes, they are lost. So have you ever wondered why the superficial reflexes are lost and the deep tendon reflexes are exaggerated? So today's class is regarding this one. Like, first of all, to understand this thing, we need to go back to the superficial reflex and the deep reflex. Like, what is the difference? What is the basis upon which we call a particular reflex as the superficial one or the deep one? It is based on the receptor, the sensory receptor. Like, I will give you an example of knee jerk. The knee jerk it's an example of deep tendon reflex, right? But the flexor withdrawal reflex, or just withdrawal reflex, I'll write down withdrawal reflex. It is an example of superficial reflex. So on which basis we are saying that withdrawal reflex is the superficial one, but deep tendon reflex is, the knee jerk is the deep tendon reflex. Knee jerk, if we go back, like say, what we do in the knee jerk, we hit the tendon of the quadriceps femoris. We will hit the tendon of the quadriceps femoris. So when we are hitting the tendon of the quadriceps femoris, this muscle, we are hitting over here, this tendon. So what is happening? As we all know, there is muscle spindle lying within this skeletal muscle. This is the muscle spindle. Okay. These red one, they are the extrafusal fiber. Extrafusal fiber. And this one, they are intrafusal fiber, right? Intrafusal fiber. Intrafusal fiber. Now, when we are hitting the tendon with the knee hammer, what is happening? It is stretching this part. It is stretching the muscle. When we are hitting it, we are stretching it. So what happens? This muscle spindle, it acts as a receptor. So the receptor, this stretching is carried by 1A fiber that is around this muscle spindle. So 1A fiber will carry the sensation to the spinal cord. Okay, it will carry the sensation to the spinal cord. Now, it will synapse within the muscle. It will synapse within the spinal cord. Within the spinal cord with alpha motor neuron, right? Say this is the alpha motor neuron that will come back. Now the alpha motor neuron innervates extrafusal fiber. This is alpha motor neuron. This innervates extrafusal fiber. And the gamma motor neuron, they might get connection from this one or from the higher center. From the higher center, it will come to both the alpha as well as gamma. So first we will talk about the higher center. Afterwards, first we will cover this thing, the alpha motor and the gamma motor neuron. Now, what is the ending point of the gamma motor neuron? Gamma motor neuron ends at this outer segment of the muscle spindle. This outer segment of the muscle spindle. And as we all know, the outer segment of the muscle spindle, it is contractile. It is contractile. This part is contractile. So when the gamma motor neuron gets stimulated, Initially, we hit the muscle tendon with the knee hammer, and after hitting the muscle tendon with the knee hammer, there will be stretching, and that stretching of the muscle spindle will be carried by 1A fiber. It will go up to the spinal cord, to the concerned segment, will form the synapse with alpha motor neuron, and alpha motor neuron will innervate the extrafusal fiber, and ultimately the muscle will contract. That is the simple flowchart or simple diagram of a reflex, stretch reflex, right? Then there comes gamma motor neuron too. It might get also stimulated from this part or from the other things. When the gamma motor neuron gets stimulated, then it innervates the contractile part of the muscle spindle. So because of the innervation of the contractile part of the muscle spindle by the gamma motor neuron, they get excited, this part will contract. Now this contraction will move this way and this end will contract this way. So what will happen to inner segment of the muscle spindle? It will again get stressed, right? It will again get stressed. So because initially just we started with the knee hammer, it will again get stressed. Again the sensation will be carried by this, and then again the alpha motor will get activated. Alpha motor is trying to reduce the size when the extrafusal fiber, because whole of them, entire of the extrafusal fiber, they are contractile. So it will try to contract in this way, but gamma motor neuron is making the muscle spindle to contract this way. That's why the alpha gamma co-activation occurs, and this is the diagram for the deep tendon reflexes, right? Now, what happens in the case of superficial reflex? Superficial reflex, this gamma motor neuron, it is totally cut off. Why? Because just take the example of withdrawal reflex. Whenever, like we are in the kitchen, we hit a hot pan, what we do? Immediately our hand will withdraw itself. So who is the one? What is the sensory receptor which perceives the sensation of the increased temperature? That sensory receptor for the pain, there will be the increased temperature, because that increased temperature will lead to the pain. So pain and temperature, these receptors, they are not located within the muscle, they are located in the skin. That's why that withdrawal reflex is called as superficial reflex. So the reflexes are classified deep and superficial based on the location of their sensory receptor. In the case of the stretch reflex, muscle spindle, it is located deep in the body. That's why deep tendon reflex, deep reflex. In the superficial reflex, the pain and temperature, that one, that sensory receptor is located within the skin. So that's why it is called a superficial reflex. Now coming to the superficial reflex, to the diagram, that pain and temperature is carried via A delta and C fiber, right? A delta and C fiber, it carries to the spinal cord. Now within the spinal cord, they will end at the alpha motor neuron, and alpha motor neuron will innervate this extrafusal fiber, right? The extrafusal fiber, this sensation is coming from the skin. This is the skin part, okay? Within that the muscle is located. So like there is a painful stimuli or increased temperature, it will be carried by the A, delta and C fiber from the superficially. It will form a synapse with the alpha motor neuron, and alpha motor neuron innervates the muscle. Muscle will contract, and there will occur the removal, the flexion of the hand, right? So that's why there is no contribution to by the gamma motor neuron in this one. Now coming back to upper motor neuron lesion. Upper motor neuron lesion is, like say, in previous class I have discussed about that flow chart that's given in the genome. I told you that's given in the genome, that's regarding the reticulospinal tract and the corticospinal tract, how they innervate. So I'll put the link of that video in the description of this particular video, okay? So you can go back and watch in the details. But a brief overview regarding that one, I'll tell you. Reticulospinal tract. There are two types of the reticulospinal tract. One was medial reticulospinal tract. The second one was lateral reticulospinal tract. Now the medial reticulospinal tract, this was excitatory. This was excitatory to whom? It was excitatory to gamma motor neuron. It was excitatory to gamma motor neuron. And this lateral reticulospinal tract, it was inhibitory. It was inhibitory to gamma motor neuron. That is one thing. And both of them, the medial reticulospinal tract or the lateral reticulospinal tract, they are innervated by the tract, the nerve fiber which are coming from the cortex and ending at the reticular. So we can call them cortico-reticular tract. Cortico-reticular tract was stimulating both of them. Both of them. That's the one scenario regarding the gamma motor neuron. Now, from the cortex, the tracts which directly come from the cortex and end at the spinal cord, they are called as corticospinal tract. Corticospinal tract. Now, these corticospinal tract, they are innervating alpha motor neuron. They are innervating the alpha motor neuron and they are stimulatory to alpha motor neuron. Stimulatory to the alpha motor neuron. Now, what is upper motor neuron lesion? Upper motor neuron lesion is the lesion of the tract. Say, if we cut this thing, like in the previous class I told you about the decorticate and decerebrate rigidity, these things. So if we do a cut over here, this point, now what will happen to the alpha motor neuron and what will happen to the gamma motor neuron? Alpha motor neuron was receiving excitatory from the higher center. So there will be loss of the excitation. So what will happen to the alpha motor neuron activity? It will be reduced. And if we go back to the superficial reflex is concerned with the alpha motor neuron. Gamma motor neuron does not play any role in superficial reflex. So that's why in the case of upper motor neuron lesion, superficial reflexes will be lost. Superficial reflex will be lost. Now coming to gamma motor neuron. Gamma motor neuron, if we cut off this section, what will happen to the lateral reticulospinal tract? Both lateral reticulospinal tract as well as the medial reticulospinal tract, they won't get stimulatory signal from the higher center. And if the lateral reticulospinal tract is not getting stimulation, it won't be able to release the neurotransmitter, inhibited neurotransmitter, and it won't be able to inhibit the gamma motor neuron, right? Now, the question arises, the medial reticulospinal tract. As I told you, they are self-stimulating. They are the neurons present in the medial reticulospinal tract, the cell bodies located in the upper bone. They automatically they are like, we can say, like the SA node is present within the heart. They generate their own impulse. Similarly, these neurons, they generate their own impulse. Automatic. If there is no stimulation, if there is stimulation, that autogenericity, like the automatic generation of the impulse, will get exaggerated. If we remove, still they are still active. They are releasing the neurotransmitter. And the other thing was, they also receive the sensation via anterolateral spinothalamic tract from the peripheral part of the body. So we have just cut in the upper motor neuron lesion this tract, not the ascending one. So it will keep on stimulating this one. So ultimately, what will be the end effect of upper motor neuron lesion on the gamma motor neuron? They will get more and more stimulated because we have removed the inhibitory part. And the gamma motor neuron plays the role in deep tendon reflexes. So because of the gamma motor neuron discharge, increased gamma motor neuron discharge, what will happen? It will make the contractile peripheral end of the muscle spindle to contract. That will get contracted. Then there will be the stretching of the muscle fiber. That stretching of the muscle fiber that sensation will be carried via 1A fiber and those 2 fiber number 2, that's like the sensory afferent neurons carrying the sensation from the muscle spindle to the spinal cord. and ultimately alpha and gamma motor neuron will make the muscle to contract more and more. That's why deep tendon reflexes are exaggerated in upper motor neuron lesion, but the superficial reflexes are lost. That's all.